Happy Monday, everyone. It's meteorologist John Homenuk with Empire Weather here with your long-range video update. Happy to join you guys again here in the start of a new week. Get comfortable. We have a lot to talk about, and I want to review the pattern and what we've seen over the last weekend. So we know we had an active pattern coming this weekend, and we anticipated storm clusters. They did happen exactly as we expected that they would. Here's your area of precipitation. You can see exactly where these clusters tracked this weekend. Really from southern Minnesota, parts of the eastern Dakotas into southern Minnesota, and then parts of northern Iowa into southern Wisconsin, as well as northern Illinois and Indiana. Big, important rains in these regions. You'll also notice that a couple areas missed, right? We initially had more widespread rain forecast here in Iowa, and some of these areas missed out on the rainfall. And that's going to be important for us moving forward here, is to look at the areas that miss and the areas that didn't. If we go and look at the latest analysis, 30-day precipitation normals over the last 30 days, right, we can see that there's a couple of really important things developing here. First of all, we have this widespread dryness that we know has been consistent across the southern plains. This area is where we have the most substantial long-term drought. We know that. But there's also areas that have missed on rains multiple times. So this includes the rains from the weekend. And I want to focus on this area right here from Iowa into southern Minnesota. Obviously, it's not the entire area, but for parts of western and central Iowa to be running at 50 to 60% of normal precipitation over the last 30 days is obviously less than ideal when it comes to impacts as we move forward here. And you can see this extends into parts of south central Minnesota as well. This area here saw the storm cluster this weekend. This parts of Iowa did not. And so it's going to be important to watch this region moving forward. We can visualize this on the stress degree day maps as well. I know we've talked about these a couple times, but we've started to use them a bit more. When you get into values over 150 or so, you start getting into a crop that is more and more stressed. And so obviously down here in the southern plains and the west central plains, we have a very stressed crop situation. We know that this has been the case here. These areas are really struggling. But look at how parts of that stressed crop are extending now into parts of Nebraska and even western Iowa. And when we go back and we look at what we just were looking at here in terms of the precipitation departures, it makes sense that this is an area that we're going to want to focus on over the next couple of days and weeks. And it's anomalous as well. This is the anomaly. So how is this compared to normal? And you can see that you can really see where the crop stress has extended to in an anomalous fashion. And this makes a lot of sense when you compare it to what we were just looking at from a departure percentage here. Just looking at the last 14 days precipitation totals, you can see that the storm track really has been from the monsoon over the top here, and there's been two pathways. Here's the first pathway, is come out of the Canadian storm track, and here's the second pathway that's come down here over the last couple of days and weeks. And so that has left this area that we just talked about drier than a lot of other regions surrounding it. And I think that's just something that we need to really be careful of moving forward. Let's look at the pattern as it stands over the next couple of days. Here's the latest NAM model. And as we move through the afternoon, we're expecting some scattered shower activity across these areas that we just talked about. So scattered showers and storms likely across parts of South Dakota, moving forward into parts of Iowa, and then into parts of Illinois and Indiana over the next several hours through tonight and into Tuesday morning. And that's when this next disturbance comes in and the frontal boundary lights up. So let's back up and look at where we are from a national perspective and why this is happening. So here's our current setup. This is one large front that is draped down here from the northeast back here into the central plains. And this front is shifting gradually southward. You can see the southward motion of it here. And by the time we get into Tuesday morning, this is where the front is. And so this frontal boundary is getting quite a bit of resistance from the south, from the ridging development over the western Atlantic and the consistent ridge across the southern plains. And so what happens is, as a result, you get what is known as a stalled front across this general region. And so all of your disturbances that come out of the Pacific Northwest and the monsoon are going to ride along that stalled front. And that's exactly what models are suggesting will happen over the next couple of days. If we look at the precipitation total forecast on the latest NAM model, you can see exactly where this frontal boundary is and the multiple disturbances that ride along it as we move through the middle of this week. Now, that being said, these obviously, similar to other thunderstorm complexes, not everyone's going to get hit. So we'll see bands of rainfall, but exactly where they end up, we're going to have to track that as we go through these next couple of days. Every model run is going to be different. Here's the latest European, and you can see this is the focus on the European model for this trough through midweek, is right through this general vicinity. But again, not everyone's going to get 1 to 2 inches of rain. The broad potential exists for that kind of rainfall during that time frame. European model does a lot of the same things as the NAM. It drops this front down. You get multiple disturbances on it through the end of the week. This is valid Thursday into Friday, so we're still going here with moisture Thursday into Friday, and it actually sinks down into the southern plains. So this is substantial as well, because this area has really missed out on moisture. So when we look at the precipitation anomalies here through the end of the week, let's roll this out 7 days and look at this region of above normal precipitation extending back here into parts of northeastern New Mexico, eastern Colorado, Kansas, Nebraska, Oklahoma, and the Texas Panhandle. This frontal boundary coming down here will provide moisture to these areas that have been extremely dry. If we look at totals, this is valid through a Sunday morning of this upcoming weekend. A broad 1 to 2 inches across this entire region thanks to this front and all that moisture, and the possibility of locally higher amounts. Here's your amounts over 2 inches possible in western Kansas and eastern Colorado, and then your secondary frontal zone here. Look at all these areas here that are getting beneficial rains. This region needs rain desperately. This part of west central Missouri needs rain. Western Kentucky and Tennessee will take the rain in southern Illinois and Indiana as well. So this is all important stuff in these regions. I do want to note again, though, look at the total precipitation forecast for central and western Iowa here over the next 7 days. Very low, less than 0.2 of an inch on the ensemble mean. So a lot of winners here, but still some losers that we need to be careful about when it comes to rainfall moving forward. So this pattern is wetter than normal, and over the next several days, if we look at temperature departures, it's also cooler than normal. You can see exactly where the gradient is. Here's the front, folks. This is your frontal boundary over the next 7 days, and that's why the models are predicting so much precipitation along it, because you have this warm, moist air just feeding into this frontal boundary that's dropping down and has nowhere to go. And so this is your stalled out region of rainfall potential over the next several days. It's also cooler than normal, 3 to 5 degrees below normal in this general region, and you have your cooler northerly flow behind it, so you're at least 1 to 3 degrees below normal for this time of year in parts of the Dakotas, Minnesota, Iowa, Wisconsin, and even into parts of the Great Lakes and the Ohio Valley, while we remain warmer than normal here in the southern plains. But what else is new when it comes to that? That precipitation risk, I just don't want to miss out on these folks either, but look at this extending into the southeast United States as well. You can see exactly where the focus is along this frontal boundary. You'll get some geographical enhancement as well from this precipitation in this area, while areas along the southeast coast will actually trend a bit drier because all that moisture is getting shunted northward and pooling along the frontal boundary. So a bit of a change to a pattern that had been very wet down here. Now all that moisture is in interior North Carolina up into Virginia and then into the Appalachians and back into the Tennessee Valley. Let's look at what's going on across the globe. So we know we have this cooler pattern over the next 5 to 7 days. We know it's wetter than normal. There'll be plenty of opportunities for moisture in those areas. If we back up and look at the areas that are going to dry out in the next 5 to 7 days, it becomes very clear that the pattern is going to be drier than normal across parts of southern Minnesota, Iowa, Wisconsin, northern and Illinois and Indiana, into parts of Michigan. And this is the area we're going to start to focus on because all the moisture now is down here. So what happens after that? Let's back up and look at what's going on across the entire globe. And the first thing I want to point out to you is how this pattern has evolved over the last really 2 to 3 months. I'm going to back us all the way up to look at the pattern that we were dealing with in May and June. And I want to talk about a couple of really key things. First of all, the La Nina was well established then, and it is well established now. We still have major upwelling of cooler waters. We still have the trade winds cranking and keeping the La Nina in play. It is remarkable that this La Nina is still doing what it's doing, but it's in control. So in May and June, we know that the pattern started to trend drier and warmer across the central United States, and the ridge was centered more in this general vicinity. The configuration of the sea surface temperatures was as such. We had a trough here, northwest of Hawaii. we had a ridge northeast of Hawaii, and then we had the trough off the west coast, which allowed the ridging to expand back to the east of the Four Corners. It was generally fluctuating in this general vicinity, and that's because of this general configuration, right? This makes perfect sense to us. When we roll forward to what happened in July, look at how those cool waters off the coast of western North America disappeared. And we started to get this major warm anomaly northwest of Hawaii. And we remember what the models did is they said, oh, wow, okay, so we're going to back up this ridge to the Four Corners region because this is what your configuration is going to look like now. And this is exactly the pattern we've had, right? We've had the active pattern here. We've had the ridging centered in the Four Corners. We've gotten our storm clusters. And this has been kind of the stable pattern that we've been in here. But look at what has happened over the last couple weeks quietly. We have seen a major area of warm water northwest of Hawaii start to expand significantly. And as it's done so, these cooler waters off the coast of North America have reemerged from the Gulf of Alaska down to the coast of the western coast of the United States. And so what this tells us is that this pattern, which was like this before, right? We had this blob here, we had the cooler waters and the ridge off the coast is going to start to move this way. And that's exactly what we're seeing on models here. I just want to point this out to you. The La Nina is still going. But this warm water, which was northwest of Hawaii, is now more north of Hawaii. And these cooler waters are reemerging off the coast. And so that argues for the possibility that we will start to see ridging expanding again back to the north and east. Let's look at the latest guidance. And I want to roll that forward here and check out the European model and what it does over the next several days and weeks. Here's our current pattern right now. I'm going to back up to North America. Here's our current pattern right now. We know we had this large ridge off the western coast of North America, which encouraged this troughing to move into the Great Lakes and central Canada. But this ridge begins to collapse on top of itself. All of that is a function of what we were just talking about with the La Nina forcing, what's happening here in the Aleutians, and these troughs that are starting to move the pattern along. That ridge collapses down on top of itself. And it also starts to link up with this very warm, very moist Western Atlantic ridge. This starts to move off to the west. And look at the expansion of heights now. So initially it starts out here in the Four Corners. This takes us to the end of July, right? And so your heat that had built in the west is still all in this general vicinity. But eventually that's going to start to collapse down to the east because the pattern is going to start to shift. We just looked at the reasons why there's support for this, but the pattern is going to start to shift. We're going to likely start to see these troughs return here, and there's the possibility that we could see this ridging expand in this general vicinity, and that's exactly what the European model says, right? We had this active pattern in these troughs, and your ridging was centered in this general vicinity. By the end of the European run, your ridging is centered back in this general vicinity. So what would this mean from a sensible weather perspective? The first thing, without further ado, is it would mean the return of warmth and the expansion of this warmth as this ridge really starts to develop here into the first and second week of August. If we zoom in and we look at the temperature departure forecast, the European takes this cooler risks and it just moves them out very quickly by the time we get through into the first week of August. And it allows for a much warmer pattern to begin to develop across a large majority of the central United States. And that includes areas that have missed out on those rains. So from the southern plains up into the Midwest, and then also parts of the Ohio Valley and the Northeast as well. These temperatures are well above normal. If we look at the 5-day anomalies and we zoom in here for the period ending on August 9th, we are 7 to 10 degrees above normal in this region, 7 to 8 degrees above normal here, and you can really see the angle of this warmth developing during this time frame as well. Now, in addition to the warmth, if we go and check out the moisture here, and I want to see, you always want to ask yourself, hey, what makes sense in this pattern? There's some idea here coming on the models that the storm track could remain somewhat favorable despite the warmth. But from a height perspective, there's a little bit more concern here than there was during the earlier pattern that this could be a little bit drier. And one of the main reasons is how expansive this ridging is on forecast models. I think you'll remember when we talked in May and June, we were very adamant that the orientation of the ridging being back here towards the Four Corners would allow those storm clusters to come over the top and down into the agriculture regions. That is still a possibility in August. But when we look at model forecasts, and this is the overall look, Your 588 highway is all the way up here in Minnesota, Wisconsin, and the Dakotas. And your ridging is expansive enough that it's going to start to affect and possibly dry out this area of monsoon moisture. So hypothetically, where's your storm track, right? You have these disturbances coming out of the Pacific, and you're likely looking at a northern plains or Canadian prairie storm track if this were the orientation. You can see that the jet energy is all north of the United States at this time. There's a lot, the core of it is up here in this general region. So there's a little less confidence in how this would go in terms of precipitation chances. Now the European does do that. Once this is our front here through the end of the week and weekend, these are 24-hour increment precipitation. You can see that washes out. And the storm track, at least initially during the first couple of days of August, is up here. It's in the north central plains in the Canadian prairies. Over time, the model starts to suggest that some storm cluster chances will return, but it's not overly wet. There's no real signal yet for how that would go in terms of those storm clusters, and with good reason, because the model is expanding a large ridge across this region, and it's likely that we would be fighting moisture going too far north to get down into the key agriculture regions during this first week of August. So let's back up here for a second. We know that we're confident in the fact that this pattern is going to change, and there's going to be some risk for things to warm up during this time frame. This ridge and trough orientation from a hemispheric perspective is different. There's support for this to be different than what we have been experiencing. Now, that being said, that doesn't necessarily mean this is going to become a very, very hot and instantly dry pattern, and we're going to just go into a furnace here. That being said, also, I think there is, the possibility that this ridge will start to expand further than we have seen it so far this year, and that we, obviously as the temperature warms up in this time frame during the first week of August, the dryness to go along with it could start to add to some stress as we move into this time frame. I think this is something to keep a very close eye on moving forward. And again, going back to this product, which we were just looking at the precipitation anomalies over the last 30 days, that's why these areas here that get rain in the next couple of days become critical. These rainfalls become critical, and that's why the missed rainfall opportunities here and here will become critical moving forward. I really think it's going to be so important to verify rains in this area over the next 7 to 10 days, and any storm clusters that can pop up and help this part of Iowa and this part of west central Minnesota, especially when you consider that the forecast trends much warmer by the time we move into the core of the first week of August and perhaps beyond that. So overall, the hemispheric pattern likely undergoing some changes. Just to recap, we have an active pattern this week. We have moisture chances across much of the south central plains over the next several days. You can see where that frontal boundary is oriented. This will be the focus over the next several days. But then as we move forward into the first week of August, the pattern looks likely to warm up. We're looking at a different orientation, and we'll have to track exactly where this moisture goes, because there's some possibility that this storm track ends up in the Canadian prairies with some residual moisture in the southeast, but dryness returning with that warmth across parts of the agriculture belt as we move into the first part of August. We will be with you all week breaking down this pattern, going through the changes in the latest weather models. There's likely to be quite a bit of volatility on these models, and it's going to be important to be able to sift through that. One side note on the forecast models themselves, the GFS ensemble has been running way, way too hot in parts of the corn production regions. This is for Iowa, so this is daily maximum temperatures. The GFS has had these problems in the past. This is a land surface feedback issue where the model cannot resolve what's actually happening, and it has a runaway temperature issue. Obviously, these individual ensemble forecasts are suggesting temperatures of 110 to 120 in parts of Iowa. That is not happening. Here's a European ensemble just for comparison, and you see those temperatures are much more reasonable in the 90s, some areas warmer in the upper 90s, and temperatures generally, if we were to look at the trend, follow with the forecast that we just talked about, right? As we get into that first week of August, you can see the forecast in Iowa, for example, goes well above normal in terms of temperature. The GFS data is ridiculously warm and likely way too warm. Should be discounted in terms of what it's showing in terms of sensible weather. Now, the forecast itself might end up a little bit warmer than the European would suggest. We'll likely see these averages trend a little bit closer to this, but the GFS data is likely way too warm, and you're certainly not going to see temperatures of 110 to 120 like this top of the ensemble members are suggesting during that time frame. So I just want to keep that in mind moving forward. We have to be careful with the model data that we do use. That being said, again, as we move into early August, that forecast likely to trend a bit drier, and it's going to come with temperatures that are going to trend warmer as well. You can really see the expansion of this warmth across the central U.S. during the first week of August. We'll be with you guys the whole time, breaking it all down. And if you have any questions, as always, please don't hesitate. Reach out. We're here to help. Otherwise, have a wonderful Monday afternoon. We'll talk to you guys real soon.